Hi, my name is Gandon.
And my name is Vivian. We decided to create a line graph to show the changes over time of New York City math scores between the two groups of economically disadvantaged versus not economically disadvantaged. We specifically chose these groups to see if we can discover if the economic status of the students will affect their scores and whether schools are putting an effort to balance out the difference in their learning needs. Our audience would be groups such as teachers or general educators who want to see if there are any trends with scores from their students' results. We start off here on the screen with a line graph of all grades, as you can see in the filter dropdown. We can see that the orange timeline represents the not economically disadvantaged, while the blue represents the economically disadvantaged. When you click on the dropdown, the user is able to select which grade in particular they want to examine, and the graph will update accordingly. The user is also able to hover over each data point to see the breakdown of percentage of the students in different levels of performance, the exact score, and the number of students tested. Now, before we highlight some of the insights generated by the chart, it's important to understand the context of dates during the time range of the data. In 2018, the test was completely overhauled, leading to very different mean scores between before 2018 and after 2018. Additionally, there was no test administered in 2020 and optional testing in 2021 due to COVID-19. The first and most obvious insight generated was the non-economically disadvantaged students had a stronger mean test score at every single data point. But even though this is true, the visualization also shows the closest mean test scores between the groups in 8th grade, suggesting that some of the advantage of being not economically disadvantaged gets balanced out as students get older. Lastly, one scary insight generated is that although mean test scores are somewhat similar, non-economically disadvantaged students have an increasing percentage of students scoring at higher levels, while economically disadvantaged students have the highest percentage scoring at the lowest levels and decreasing percentages at higher math levels. As our audience uses our visualization to examine the data regarding math scores of the students within the two groups, they are able to utilize the tooltip and filtering to interact with the visualization to find their desired insight, whether regarding the general population or by the grade specifically. They are also able to understand the context better with the notes and annotations provided on the visualization itself.